in the sense frequently you will face these type of functional relations in the problems. Okay, instead of giving these functions directly, the question gives you about this functional relation, and by observing this functional relation we need to identify the function as kx. If you have this functional relation, then you need to identify that f of x as k power x. So by observing the given functional relation, we need to identify the function and then we will solve the problem. Sometimes it is somewhat difficult to identify the function, then without identifying also we will solve. Okay, and in particularly if you have a look at this, see, these are the functional relations. Okay, and those are the functions which are satisfied by these functional relations. For suppose if you wish to check any, let us go for the checking. Okay, as we discussed in the previous class, if f of x is some x power k, then surely what, f of y is y power k. So replace f of x with x power k, f of y with y power k, and this side xy to the power k. Okay, and whereas this side f of xy, directly we will write it like xy to the power k. Both sides are get balanced, and so we say this function is related to this functional relation. Okay, have a look. Okay, some more standard functional relations this, and the previously mentioned functional equations are the algebraic relations, whereas these standard functional relations or the equations are trigonometric functional relations. See, just have a look. See, we know different trigonometric formulas, and then these functional relations are just related to those trigonometric formulae. For suppose f of x plus y, I mentioned it like this. I think you all know about sin of x plus y. Is it right? Okay, I will write you. Okay, just have a look. Sin of x plus y is equals to sin x into cos y plus cos x into sin y. Is it right? Sin of x plus y is sin x into cos y plus cos x into sin y. Okay, and we have a chance to rewrite this cos y as square root of 1 minus sin square y. Square root of 1 minus sin square y is cos y only, and this sin y is simply nothing but square root of 1 minus, okay, I will write this cos x. This cos x can be rewritten as square root of 1 minus sin square x. Just have a look the situation. The statement is completely in terms of sin. Sin of x plus y is equals to sin x into this root of 1 minus sin square y plus cos x into root of 1 minus sin y into root of 1 minus sin square x. Okay, this is cos x, right? We rewrite the cos x as like this. So that in the sense, now observe this statement, the first functional relation. You just observe this first functional relation as well as that compound angle result sin of x plus y. When you compare these two, this functional relation is just corresponds to the function sin x. So instead of giving the function as sin x directly, sometimes the question may give you this functional relation. F of x plus y is equals to f of x into root 1 minus f square y plus f of y into root 1 minus f square x. This functional relation is just related to the function sin x. If you wish, you just check it as I mentioned you. You just start with the right hand side and easily you will arrive to the left hand side. Yeah, my idea of the function is sin x, right? You just start with the right hand side. Okay, whether it is right or wrong to check. See f of x. See, f of x is sin x, so my right hand side is also sin x into root of 1 minus f square y. Since f of x is sin x, f of y is sin y, f square y is sin square y, 1 minus sin square y, you know, cos square y, root cos square y is cos y. This is root of 1 minus sin square y. Okay, right. Plus f of y. F of y is sin y into root of 1 minus sin square x, because it is root of 1 minus f square x. So this is simply nothing but sin x into cos y plus sin y into cos x, and this is equals to sin of x plus y, and sin of x plus y is simply nothing but f of x plus y, which is the left hand side. So both sides are balanced if the function is sin x. Okay, we just have it. So for the functional relation, f of x plus y is equals to f of x into root 1 minus f square y plus f of y into root 1 minus f square x. The corresponding function is sin x, and this is the one standard functional equation involving the trigonometry. In a similar way, if you check the second functional equation is just corresponds to the function cos x. If you take f of x is equals to cos x, cos of x plus y is equals to cos x cos y minus sin x sin y. So this is the relation and that is the function. And the next thing is f of x plus y plus f of x minus y is equals to 2 into f of x f of y. So the corresponding function is again cos x only. For this functional relation, again the function is cos x. Why? Because f of x plus y. F of x plus y is how much? Cos of x plus y plus f of x minus y. This f of x minus y is what? Cos of x minus y. Cos of x plus y plus cos of x minus y. If you simplify, this is 2 cos x cos y. 2 cos x cos y is simply nothing but 2 into f of x into f of y. That in the sense these two are equal if that f of x is equals to cos x. So for this functional relation, functional equation, the function is cos x. In the same way, if you check for the last one, here your f of x is what? Sin x. Sin of x plus y plus sin of x minus y is 2 sin x cos y. So that's I mentioned here. Okay. So these are some standard functional equations related to the trigonometry, and the previously mentioned relations are corresponding to algebra. So the questions and the problems usually, instead of mentioning the function directly, they will give you the functional relation. By analyzing the given functional relation or equation, we need to identify the corresponding function. So for such identification, these standard functional equations are very helpful for us to identify the function. Okay, have a look. So these are some simple problems related to the functional equations. Okay, so already I mentioned you the standard functional relations. Using those standard functional relations, we need to solve this. And in the next number, like 49, I will give you some problems which are not related to the standard functions. Okay, and now all these are the standard relations. You just identify the standard function, directly apply it, easily you will solve the problem. See, when you look at the first problem, f of x plus f of 1 by x is equals to f of x into f of 1 by x, and corresponding to this function, as I mentioned you, the corresponding function is 1 plus or minus x power n. Okay, this is the functional relation. We don't know whether it is plus or minus. According to the other conditions, we need to choose that plus or minus. F of x is 1 plus or minus x power n. And now, if you look there, as they mentioned, f of 2 is equals to 7. Our idea is the function is in this format like 1 plus or minus x power n, and the problem is given like f of 2 is equals to minus 7. So, what to say? If this is f of x, then what to say f of 2? F of 2 is simply nothing but f of x is 1 plus or minus x power n. F of 2 is replacing x with 2. So you will get that 1 plus or minus 2 power n is equals to minus 7. Okay. From there, we need to calculate n. Here we have two choices, right? 1 plus 2 power n is equals to minus 7, or 1 minus 2 power n is equals to minus 7. So because of the space I am using here, 1 plus 2 power n is equals to minus 7, or 1 minus 2 power n is equals to minus 7. When you look at the first situation, 2 power something is always positive, plus 1 is positive, but it is minus 7, not possible. Then think about the second situation. 1 minus 2 power n is equals to minus 7. So if you observe it clearly, the value of n is what? 3. Okay. So 2 power n is 8 and n is equals to 3. So from there n is equals to 3 and the relation is 1 minus 2 power n. So we will finally conclude that our function is f of x is equals to 1 minus x power 3, because n is fixed as 3 plus we neglect it. So 1 minus x power 3 is the function f of x, and the question is to find f of 3. Now replace x with 3. F of 3 is equals to 1 minus 3 cube, and your answer is minus 26. 1 minus 27 is minus 26, right? And that's the problem. So if you are comfortable in identifying the function as 1 plus or minus x power n, then the problem is very easy. Or otherwise, you need to find out the function by analyzing this functional relation, and that is somewhat bit complicated, and it took some time, okay? So if you observe this type of functional relation at any time, you need to think about this particular function, and which is 1 plus or minus x power n. From there we calculated n as 3. At the end the function is 1 minus x cube, and the required answer is minus 26. There ends the first problem, right? Have a look. So the next problem is f of xy is equals to f of x plus f of y, and f of 3 is equals to log 3 base 10. And then we need to find this particular value, f of 1 into, f of 2 into, f of 3 into, and so on, f of 100. Okay, so we don't know f of x initially. After identifying f of x, we need to calculate f of 1, f of 2, f of 3, like that up to f of 100, and we need to multiply everything. So for that, first of all, you need to think about the given functional relation. F of xy is equals to f of x plus f of y. As we discussed, this functional relation is corresponding to the function f of x is equals to some a into log x to the base k. But one more value is given, f of 3, which is equals to log 3 base 10. Since f of 3 is log 3 base 10, 3 and 3 are matched, okay? And that's why x and x, okay, here 3 and 3. So you just take that a is equals to 1 and x is equals to 3. From there, since f of 3 is equals to log 3 base 10, we will confirm that f of x is equals to log x base 10. If f of x is equals to log x base 10, f of 3 is log 3 base 10, both are balanced. So at the end, see, this is the general function, but with this condition, this is the particular function which we require for the problem. F of x is equals to log x base 10. And now f of 1, f of 2, f of 3, log 1 base 10, log 2 base 10, log 3 base 10, like that we need to multiply. But the first term is f of 1. F of 1 is what? Log 1 base 10. Log 1 value is 0. Since this is 0, the total product is 0, and your answer is again 0. There ends the problem. Okay, this is 48b. In a similar way, if you think about the next one, 48c, f of x plus y is equals to f of x into f of y. Again, it is a standard relation, and corresponding to this standard relation, as I mentioned you, f of x is equals to some constant to the power x. K power x into k power y is k power x plus y. Okay, this is the general function. But in particular, it is given as f of 7 is equals to 1 by 3 power 7. See, f of x is equals to k power x, and there they mentioned that 7 and 7 match, x and x match. So you need to fix that k is equals to 1 by 3. So in particularly, we will consider our required function as 1 by 3 to the power x. If our function is 1 by 3 to the power x, then f of 7 is equals to 1 by 3 power 7 is balanced. So now f of x is equals to 1 by 3 power x, then what you say about the sum of these infinite terms? And now, see, we need to calculate all these things. F of 1, see, f of x is 1 by 3 power x, f of 1 is 1 by 3 power 1, f of 2 is 1 by 3 square, f of 3 is 1 by 3 cube, and so on up to infinite terms. When you look, all these terms are forming a geometric progression with the common ratio 1 by 3. Okay, I think you are all aware about the geometric sequence of infinite terms, and the sum of all these terms is, the general rule is a by 1 minus r. First term divided by 1 minus the common ratio. Here the first term is 1 by 3 and the common ratio is still 1 by 3. So you just replace a with 1 by 3 or also with 1 by 3. When you simplify, your answer is 1 by 2, and there ends the problem. So to solve this type of problems, initially we need to identify the function related to the given functional relation. If you have those functional relations along with functions in your mind, then you feel somewhat easy to answer these problems. Okay, have a look. Just look at the board, the first one. 2 into f of x plus 3 into f of 1 by x is equals to 1 by x minus 1 by x minus 5. Then we need to find f of x. So I will solve the first problem. In a similar way, you can solve the second one also. Okay. With this given functional relations, we need to find out the function. See, these are not standard. We need to think about the function, we need to analyze it, and we need to solve. Okay. First of all, you just pay attention on the first problem. I will find f of x. You just take the second problem and then you will solve it afterwards. Okay. You just take it. I will erase it for the space concern. You just have a screenshot for the second one. I will erase it for the space and I will deal the first. Okay. I am erasing. Right. Both are of the similar type. No need. Okay. No problem. Yeah. Just think about the first one. 2 into f of x is equals f of x plus 3 into f of 1 by x is equals to 1 by x minus 5. Then find f of x. Just observe the problem. Okay. See, to find f of x, here x and here 1 by x is there. What I do is, I just replace x with 1 by x. Replace x with 1 by x. Why? Because here x and 1 by x are there. I need to find f of x. So I am trying to make a relation, another relation, okay, which connects f of x and f of 1 by x. So you just replace x with 1 by x. So then what will happen? Then 2 into f of x will become f of 1 by x plus 3 into, we are replacing x with 1 by x, so 1 by x means f of x. 3 into f of x is equals to 1 by, replacing x with 1 by x means 1 by x is x minus 5. This is the given relation and this is the new relation which we formed from the given one by replacing x with 1 by x. See, just look at the given one as well as the new one. And we are going to find f of x. We don't need this f of 1 by x. So we need to eliminate that f of 1 by x. So how to eliminate that f of 1 by x? See, we have two particular relations with us. And since we are trying to eliminate that f of 1 by x, see here 3 into f of 1 by x, here 2 into f of 1 by x. Multiply the first relation with the 2 and the second relation with the 3 and then subtract it. There ends the problem. Yeah, I do here, okay. The first relation when you multiply with 2, what will happen? First relation with the number 2. 2 into f of x plus 6 into f of 1 by x is equals to 2 by x minus 5. Okay. And the second relation is this, and I am multiplying this second relation with 3. Now what will happen? 3 into 2, that means 6 f of 1 by x. 3 into 3 is 9. Plus 9 f of 1 x, 3 into x is 3x minus 15. Here again you multiply with 2, right? Here also I need to write 10. Okay. So first relation multiplying with 2 and second relation multiplying with 3. Since I need f of x, just do subtraction, eliminate f of 1 by x. Okay. So if you do subtraction, minus minus minus, these two will get cancelled. 4 f of x minus 9 f of x is simply minus 5 into f of x. This is equals to what we need to take here. 2 by x minus 10 minus 3x plus 15. Because minus 3x minus of minus plus 15. This is the result at the end. Since we need f of x, send that minus 5 that side, everything, okay, no problem. From there I am using this case, okay. Now, yeah, 5 into f of x is equals to, first of all, 15 minus 10 is 5, okay. Or see, minus I am sending that side, minus 3x when you multiply with minus 3x minus 2 by x, 15 minus 10 is plus 5 and then minus 5. So this is 5 f of x, again send that 5 this side, you will get that f of x at the end it is, see, 1 by 5 of 3x minus 2 by x minus 5. So this is the function, okay. Here the question is asking us to find f of x. If it is objective, sometimes they will ask you to find f of 4. For suppose if they ask us to find f of 4, after finding f of x, replace x with 4. Okay, this is one type of problems. Okay, functional relation is given, but it is not standard, and we need to find f of x, and that's why my idea is replacing x with 1 by x, so I have another second relation. So by analyzing these two relations and on subtracting, we have f of x. Okay, have a look. Two f of xy is equals to f of x to the power y plus f of y to the power x, and f of 1 is equals to 2. We need to find sigma r running from 1 to 100 f of r. See, first of all find f of x, and then it is easy to solve. See here, f of xy is given. I need to find f of x, but here f of xy is given. So if I replace y with 1, then automatically I will get f of x, right? With that basic idea, this is the given functional relation. Okay? In that, you just take y is equals to 1, then what will happen? Just have a look. If you replace y with 1, then see, 2 into f of x into 1 is equals to f of x to the power 1. Okay? Plus f of 1 to the power x. Okay, just have a look. And now, see, x into 1 is x, right? So this is 2f of x. 2f of x is equals to f of x power 1 is again f of x only. Plus f of 1 is already given as 2, so which is 2 power x. 2f of x is equals to f of x plus 2 power x. Send f of x this side. You will get 2f of x minus f of x as f of x. F of x is equals to 2 power x at the end. Since f of x is equals to 2 power x, we need to find this particular value. What it is? Sigma r running from 1 to 100 f of r. F of x is 2 power x, f of r is 2 power r. So which is simply nothing but 2 power 1 plus 2 power 2 plus and so on plus 2 power 100. Again they are forming a geometric progression with the common ratio 2, and the first one is 2. They are the finite number of terms, not infinite. Okay, so the usual formula is a into r power n minus 1 by r minus 1, sum of n terms of GP. Here a is the first term, which is 2. 2 into the common ratio is again 2 power 100 minus 1 divided by 2 minus 1. The denominator 2 minus 1 is 1 only, and your answer is 2 into 2 power 100 minus 1. So at the end, this is your answer. And see, identification of the function is the major part of this problem. Okay, have a look.